Hello everyone, my name is Sanjaykumar Katke. I am a student of B.Sc second year from Adarsh College Hingoli. Today I am going to represent Bolzano-Weierstrass Theorem for sequence. The statement for the theorem is every bounded sequence has a limit point. Before going further, we need to recall some points. The first point will be what is a bounded sequence, and second point will be what is a limit point. Let's start with bounded sequence. Sequence is said to be bounded if and only if the sequence is both bounded above as well as bounded below. For an example, if sequence Sn is equal to 1 by n, then its terms will be 1, 1 by 2, 1 by 3, 1 by 4, dash 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 to 1 by n for all n belongs to capital N, where 1 will be its upper bound and 0 will be its lower bound. So we can say that the sequence is bounded above as well as bounded below. And the sequence 1 by n is bounded sequence. Now, what is the limit point of a sequence? If a sequence Sn is a sequence of real numbers, and P is said to be its limit point if and only if P minus epsilon to P plus epsilon contains infinite terms for every epsilon greater than 0. For an example, if sequence Sn is equal to 1 by n, then terms will be 1, 1 by 2, 1 by 3, 1 by 4, dash 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 to 1 by n for all n belongs to capital N. Then we can say that 0 is the limit point of the sequence 1 by n. Now let's prove the theorem. Let sequence Sn be a bounded sequence and S is equal to Sn such that n belongs to capital N, be its range since the sequence is bounded. Let its range set S be also bounded. Now there will be two cases. First, S is finite, and second, S is infinite. Now see the first case. If S is finite, there exists at least one number xi belongs to S such that Sn equals to xi for an infinite numbers of values of n. This means that every neighborhood of xi minus epsilon to xi plus epsilon of xi contains Sn for an infinite number of values of n. Now let's see an example for case 1. If sequence Sn is equal to minus 1 raised to n for all n belongs to capital N, then the sequence Sn equals to minus 1 and 1, which is finite. So there are only two terms, minus 1 and 1, where minus 1 will be its lower bound and plus 1 will be its upper bound. So we can say that the sequence is bounded and the limit point of the sequence will be 1. Now let's see the case 2. If S is infinite. When S is infinite, since it is a bounded and has at least one limit point, say xi, my Bolzano-Weierstrass theorem for set, which state that every bounded infinite set has a limit point. Again, since xi is a limit point of S, that is every neighborhood of xi minus epsilon to xi plus epsilon contains an infinite member of S. That is, Sn belongs to xi minus epsilon to xi plus epsilon for an infinite values of n. Hence, xi is a limit point of sequence. Now let's see the example for case 2. The sequence Sn equals to 1 by n for all n belongs to capital N. Then the sequence Sn equals to 1 by n. Then terms will be 1, 1 by 2, 1 by 3, 1 by 4, to 1 by n for all n belongs to capital N. Here the terms are countable infinite. There are many terms which lies between 0 to 1, and the sequence still has a limit point which will be 0 in this case. Hence we can say that both uh, both the both the possibilities has a limit point. Hence we can say that each sequence has a limit point. Thank you friends for watching.